This video will provide examples of how Skillskin is currently producing and assembling 2 products for Kaiser aluminum. For this design challenge, we have listed 11 separate challenges, and teams may choose to tackle any number of challenges, electing to tackle a single challenge or multiple challenges. Welcome to the Skillskin staging and production area. This is where all the magic happens with our Kaiser wire project. Currently, production is located in an open area in the rear section of our building. For your information, there is standard distribution voltage in the area but no compressed air. The area is currently open to foot traffic, so that is something to take into account. More area could be dedicated to this project if necessary. Wire spools are transported to the production area on a pallet. A new spool is turned on its side, a metal mandrel is inserted, and the 35-pound spool is picked up and mounted onto a stand like this. As you can see here, Skillskin uses 2 different stands for staging of 2 different spools of wire.
Your challenge: transport and stage the wire.
Currently, we use a device like this to measure the length of the wire. The length is determined by the product order, and this video will demonstrate the process. One end of the wire is attached to the wheel and the length is measured by counting turns of the wire around the wheel. When the proper length is achieved, the wire cutters are used to cut the wire slightly long by about a half turn. This provides enough wire to secure the coil. A common wire product is measured to 16 turns for 50 feet or 10 turns for 30 feet. To finish off the coil, both ends of the wire are twisted in opposite directions around the coil itself.
Your challenge: measure the wire.
Both the red and yellow wires are stripped of 1 to 1.5 inches of insulation. This is what the stripped wires will look like.
Your challenge: strip the wire.
The stripped ends of the wire are then twisted together by inserting them into a wire nut which has already been placed inside the chuck of a drill motor. The wires are twisted approximately 5 to 7 times. The drill is operated at slow speed until the finished product resembles this image.
Your challenge: twist the wire.
The wires are welded. Welds are located at the middle section of the twisted wires for one particular product, which leaves about ½ an inch of stripped, twisted, and welded wire at the end. A different product requires a weld at the very end of the twisted wires, leaving about 1 inch, so that 2 different lengths of stripped, twisted, and welded wire ends are achieved. The wire ends look like this when welding is finished. Here is an example of the shorter weld, and here is an example of the longer weld length.
Your challenge: weld the wires.
This demonstrates the process from stripping the wire to twisting the wire to finally welding the wire. These are the tools that are used for the next couple of steps in the process: a small Phillips head screwdriver and 2 open-end wrenches. This is a close-up of the open connector used in step 6, and this is a close-up of the finished and assembled connector. This demonstrates how the connector is currently assembled. The yellow connector is opened with a handheld screwdriver. The stripped wire ends are inserted into the connector with the red inserted into the negative slot, and then the yellow inserted into the positive slot. The wires are secured with a screwdriver, and once secured, the connector is closed up again with the handheld screwdriver.
Your challenge: assemble the connector.
Next comes the stainless steel bolt assembly. This is what is required. Note that this involves the wire with the longer 1-inch welded wire end. The 1-inch twisted wire is curled around a finger into a kind of semicircle as shown. The end product of the bolt assembly should look like this. First, the two washers, the lock nut and the nut, are placed on the bolt. The curved wire end is inserted in between the washers and the nut is tightened with the use of two handheld wrenches.
Your challenge: assemble the bolt.
This image demonstrates what the finished product should look like. For a second Kaiser wire product, 12-foot lengths of 1/4 inch aluminum tubing is cut into 4-inch sections. A handheld tubing cutter is used for this process, and here is a close-up of the measured tubing being cut.
Your challenge: cut the tubing.
This is a close-up of the tube punching machine and placement of the tube. This is a close-up of the hole punched tube. Each 4-inch length of aluminum tubing is placed into a device and a hole is punched as shown. A lever is manually depressed, punching a hole about 1¼ inch from the end of each tube.
Your challenge: punch the aluminum tube.
This is the welded wire. Note, this is where the shorter weld length is used. And here is a close-up of the wire at its insertion point in the tube. The end of the stripped, twisted, and welded wire is inserted into the punched hole. The wire is pushed through the tube like this until the tip of the wire is barely showing out of the end of the tube.
Your challenge: insert the wire.
This is a close-up of the compressed tube. Note how the welded wire is protruding from the end of the tube. Using the compression device in the photo, the end of the tube is manually compressed with approximately 1/4 inch of the wire protruding. This demonstrates the compression of the tube.
Your challenge: compress the tube.
When Kaiser wire products are finished, the wire coil itself is tagged with lot number and reel information. Bundles are labeled with purchase order number, product description, lot number, and reel information, and then they're ready to go. So there is the entire SkillsChem process for producing Kaiser wire products.